All right. Well, I want to welcome everyone to the RCR Wireless News Policy and Diameter Signaling webinar. My name is Dan Meyer. I'm Editor-in-Chief of RCR Wireless News. Today, I will be joined on this webinar by industry analyst Jennifer Pigg from Battle Green Research and Dakota Dunne from Tekelec to take a look at the current state and trends in the policy and diameter signaling market. The plan for today's one-hour webinar is to cover a handful of topics concerning the market and provide an overview of the ecosystem, some context as to how the space is evolving, some challenges impacting the space, and what the future could bring. For additional follow-up on this topic, we will be releasing a report on this subject this week that will be available on the rcrwireless.com website, so please look for that. For those of you who may have stumbled upon RCR Wireless News here, looking to get some information on the space, here's a slide giving some background on us. We've been covering the mobile space for more than 30 years and have a pretty lengthy history in covering the wireless industry and the wireless ecosystem. As I mentioned earlier, joining me on today's call is Jennifer Pigg from Battle Green Research. Jennifer, thanks for joining us today. Would you please just give us a quick background on yourself and on Battle Green, too?
Thanks, Dan, certainly, and good afternoon, everybody. My background is in carrier infrastructure. This is an area that I've been researching for the past 20 years. God help me. And a lot of the work that I do happens to be related to the protocol stack, in addition to the hardware. So diameter and diameter routing is something that's near and dear to my heart.
Very good. Appreciate it. Thanks so much, Jennifer. And also joining us today is Dakota Dunne from Tekelec. Dakota, thanks for taking the time. And would you, I guess, give a quick background on yourself and on Tekelec?
Sure, I'd like to. Thank you very much. My name is Dakota. I'm the Senior Product Manager for the Diameter Signaling Router product offered by Tekelec. It's one of the products in our Broadband Network Solution portfolio. Many might be familiar with some of the material we've been giving to the industry lately. We believe we're the architects of the new diameter network, which is, critically composed by, diameter signaling policy rules engines as well as subscriber data management platforms. We've had a lot of great experience and successes on all these product lines around the world, and have been having a lot of fun engaging with customers on the future of these mobile markets. Great.
Well, thanks, Dakota. Appreciate that. Well, thanks, everyone. As I mentioned, we plan to cover a handful of topics today, kind of including an overview of the current policy and diameter market, taking a deeper dive into various systems or segments of the ecosystem, and looking into the future of the space. The plan will be to leave 15 minutes or so at the end of the presentation for questions from those of you listening in. Please feel free to use the question function on the GoToWebinar tab there on the screen to send in those questions, and we'll try to get to as many of those as we can at the end of the presentation. If you have a question for a specific member of the panel, please put their name at the beginning of the question, and we can try to target that question towards that person. For those of you who might be having audio difficulties, we get that sometimes on webinars. We will try to speak as loudly as possible, and for myself as slowly as possible. But please make sure to check your audio settings also on your computer. Sometimes we find that people just don't have the speakers hooked up or set up right. So hopefully that'll take care of those situations. So again, what I want to do for I guess a quick overview of the diameter market is, here are some numbers that we pulled out of the report that we're putting together this week, just kind of looking at the market, kind of looking at the trends and growth potential coming for the market. One thing I noticed when working on this report was kind of the growth projected for this market. It's not so much a small market now, but the growth potential for it seems to be pretty significant over the next 3 to 4 years, with most analyst firms that are covering the market projecting some pretty big growth projections. So obviously it's a market that's perhaps still in the early stages. Still some carriers looking to get into the space, but it's a market with lots of potential. So I think it's a good time to kind of touch on some of these topics now. So with that, what I want to do now is bring Jennifer back on, and Jennifer has a bit of a presentation for us on kind of on the market, her view of the market. So it's kind of an outside analyst looking in on the market, but saying that, as Jennifer said, she has quite a bit of experience in this market, so she's got some good details on it as well. So Jennifer, thanks a lot for joining us again, and we'll start off with you with your presentation. Jennifer, you there? No, Jennifer? Okay.
Sorry.
Oh, there you
go. Yeah, rookie mistake. I could have sworn it said unmuted, but that on me.
The mute button. It's always everyone's.
The mute button.
Yeah. So anyway, sorry about that. Okay, so yeah, so maybe just want to start off with your presentation there.
All right, thanks.
No problem.
So earlier this week, the GSMA, the GSM Association, reported that there are now 113 commercial LTE networks and 360 operators that are investing in LTE. Now, Yankee Group expects that between 2012 and 2014, the global number of LTE subscriptions will increase from more than 20 million in 2012 to 133 million. So this is a nice growth network that we're talking about here. As we're moving into this broad global adoption of a single radio standard, before the next one comes along, of course, we're talking about some high-scale implementation of the LTE that drives, of course, down the device unit cost, the cost of the goods sold. Theoretically, this is going to translate into some cost savings for the service providers, perhaps some attractive pricing on the side of the end users. It likewise is enabling highly scaled device markets to emerge. So we're looking at a fairly rosy picture, if all emerges as it should, with markets sustaining a wider variety of devices and both large and small operators using LTE for their future needs. So LTE is nicely positioned for growth. Now, but LTE, as a transition to LTE, is only one step in handling the traffic growth that we've all been seeing on the network. We also are seeing an investment in small cells, and small cells as a potential way to provide better coverage. And the two main concerns that the operators have moving forward are, and almost the exclusive concerns, are capacity and cost. How can we increase the capacity and coverage of the network and yet maintain cost control? So perhaps it's going to be through small cell and the deployment of a wide variety of small cells in the urban canyons that are giving us a ratio of small to macro cell anywhere from 3, which is what Ericsson is saying, to 30, which some of the smaller vendors are saying might be the ratio. Or we're going to transition to something called a cloud RAN, where we have separated the head end from the base station, and with most likely a fiber network, or potentially with the use of some emerging protocols, the use of wireless, although that definitely is a future. We're going to separate that, the radio and the base station, and provide some baseband pooling in the cloud RAN. That is still a ways off because of its dependency currently on fiber, and we see mostly Asian carriers looking at that right now, and driven to a large extent by folks like China Mobile. And then with release 10 of the 3PP standard and the HETNET standard, we're going to be optimizing the way we support multiple technologies on a single unit, and are able to consolidate multiple generations of RAN technology, and even support a number of different vendors on single units with any luck. All of this is in aid of supporting traffic growth that's increasing about 40% per year overall. But what we have not taken into account fully enough is the increase in signaling traffic. signaling traffic is growing at the blistering rate of about 250% per year. And I believe, and Tekelec is going to be speaking about that a little bit later, but completely dwarfs the growth of the data traffic itself. And keep in mind, in an LTE network, there is no separate signaling channel. Everything is IP. Everything is handled on the same channel. So how do we deal with all of this signaling traffic in an effective way and achieve those goals of the carrier to lower their costs while supporting the capacity requirements of the emerging network? So as you'll see, if we look at how RAN and signaling is evolving on the network, unlike all of our previous generations of the mobile network, 4G is all IP, access to core. The transition to all IP brings with it several advantages in terms of it's flexible, it's lower cost, better use of the bandwidth, we can have a nicely meshed network with great service ubiquity, but it also introduces a number of challenges in terms of security. How do we authenticate and support our own network and secure our own network while when everybody is on this ubiquitous IP network? It has challenges in terms of charging, policy management, support for key revenue-generating applications such as voice. Is our LTE and our all-digital voice going to be as good as we have known in the past? Well, not so great on the mobile network, let's be frank. But still, voice is a key revenue-generating application until just recently when data actually has been overcoming it. Still, we have to be able to support voice, video, rich messaging. In addition to SIP for LTE, and IMS, one of the key IP signaling protocols is diameter, which we're talking about today. Diameter is going to enable the exchange of policy messages within and between networks. It's integral for mobility management, for QoS, for quality of service enabled services, including external and internal roaming support for both voice and data. And initially, LTE is going to be predominantly deployed to support, and we've seen this, supporting for broadband data services. But as we evolve to supporting IP voice and messaging, there are a number of questions that we have to be able to answer. Can the diameter environment scale sufficiently to withstand the volume in large-scale operator deployments? How can we sustain diameter session state across multiple data centers and network elements to support new kinds of charging and policy frameworks? So we want to enable end-to-end session control. What are the requirements to interconnect the network elements from a diverse number of vendors? And can the operators count on interoperability as we all move to this diameter environment? And then also essential to the subscriber experience and revenue, how will LTE roaming work using the IP network? So policy exchange is at the core of these issues, as we see in this next slide. It's instrumental in providing authentication, mobility, QoS, charging information, as well as supporting the voice and data session roaming between the home and visited networks. Up until recently, most of the policies that we've seen out there has been targeted at this first signal circle on the upper right. It's traffic management and fair use cases. But each one of these elements on the second tier of our triangle should come into play in an intelligent network and an intelligent LTE network. So there are all sorts of elements about the user that you need to know in this intelligent network. What type of user are they? Do they belong to a family or a business that you have to take into account when charging? Do they exhibit a specific type of behavior in terms of heavy on the video side, very light on the voice, or heavy on messaging? Are they a specific type of user in terms of do they belong to a specific charging plan. And then there are time elements, time of day, time of week, etc. There are network elements. Which type of network is this session being handled on? If one of the networks gets congested, can I offload the traffic to a lower cost bearer? What's the content that I'm handling, and what are the content characteristics? Is it high delay, low delay? Is it low traffic, but also very low latency demanding applications such as voice? Is it going to be heavily buffered video, which is not latency sensitive, but is high bandwidth demanding, et cetera, et cetera? And then location. Am I roaming? Am I not roaming? So as our policy architecture evolves to take into account all of these different elements, we move from a policy environment which only was about, can I get the traffic across the network? What are the traffic management characteristics? And am I treating everybody fairly? To charging more from an application perspective, and then charging and establishing policies that allow me to create a policy architecture that is targeted and highly individualized services, and that's what we're after. Okay. So we have all of these elements coming into play as we're talking about our migration to LTE, an intelligent network, and the use of diameter. We have a control plane that's handling the policy, the charging, diameter signaling, all of our subscriber management. We have issues in the small cell as we start to think about rolling that out, how are we going to handle the backhaul? What is the signaling like going to be to the small cell? What types of policy can I roll out? And how can I manage these small cells? As our operators suddenly increase the number of their base stations by a factor of anywhere, as we said, from 3 to 30. And suddenly they're looking more like a cable operator that's having to manage all these set-top boxes. You know, the cell as a set-top box. How do we manage that environment? Carriers are really not used to that. And how can we get some help in that in the way that we scale our control plane and policy? Backhaul, of course, an issue in and of itself. The carriers have proven to be extremely Machiavellian in the way they deploy backhaul, whatever's going to work. And another element that we're going to be using for scaling is just better, faster, cheaper devices and more intelligent devices. If we look at the next slide, where can we, in this environment, where can we get into trouble with diameter? First, just overall inadequate capacity. Secondly, and this is something that we've seen a lot in terms of signaling problems, if you look at any major, some of the really dramatic major network outages in recent years, what they've been caused by is a network element fails, and it results in a failover registration storm where one RNC in the network goes out, and suddenly, in order to support those users, everybody is trying to re-register on the remaining RNC. And this is what we saw. There was a very dramatic outage in well, basically all the major carriers we've seen have experienced an outage of this nature. And any type of registration storm, it could be either caused by a device outage or it could be caused by some sort of promotional event, sporting event, where suddenly everybody is creating a huge amount of signaling traffic. Aggressive mobile devices, applications that require that are pinging the network every hour just for updates. Social media is an extremely active user of a heavy user of signaling traffic. There have been situations in sporting events, for example, where the operator has assumed that there would be heavy data traffic increase as users took pictures of what was going on and sent it off to their pals saying, haha, I'm here, you're not. But in fact, what they found was that these users were logged onto their social networks. The social network had to keep track of where everybody was as the user continued to update their status and saying, got a point on the, whatever they happened to be updating on their own homepage. It was the signaling traffic keeping track of where everybody in their network was that was a surprise. And that really caused some complexities for the network. And then the rest of it was correlated network failures or events, uncorrelated network failures and events, congestions that are causing message loss and other network elements that require retransmission of a variety of signaling, and DDoS, distributed denial of service attacks, which will create very dramatic signaling storms and are complex to try and control. So what do we see as some of the impacts of this on the network? Well, your diameter interface, as we see here, it is defined for signaling between many core network nodes and services. And so there's diameter interfaces that are connecting all of these devices, and without any type of centralized diameter router or diameter service control device or policy exchange controller, whatever you happen to call it, without that, you have a huge amount of diameter signaling that's occurring between your HSS, your MME, your charging system, your policy control system, and all of your enforcement points, all of your policy enforcement points. So this can look like a real spaghetti if you just trace the signaling between all of these events, all of these devices. It can look fairly hair-raising. Yeah, so if we look at the interfaces that we're talking about here, I've listed for you on this slide the predominant ones that we've seen, with the exception of one which I'll get to in a minute. However, there are more than 85 diameter interfaces that are defined by the IETF. The 3GPP, the 3GPP2, ETSI, T-span, packet cable, the multi-service switching forum. Everybody has an idea. The ITU, everybody wants in on defining these interfaces. They cover a range of network functions, and I've highlighted some of the dominant ones here. Mostly, we've been seeing a lot of GX, GY type of implementations that are governing a lot of your QoS and policy. They're also sort of standing in as main interfaces into some of the charging systems. However, the SY interface, which is not listed here, is the one that we'll see as the dominant interface for communication between the policy control system and the online charging system. The SY interface is effective in that it reduces a lot of the back and forth messaging between the policy system and the charging system. So they're not always updating each other about, have I reached my quota yet for data? No, not yet. Well, how about now? No, not yet. Well, how about now? No. So it's a little bit more effective at dealing with that, and with keeping balances available on the customer accounts. I'm not giving you a lot of time to talk here, Dan, am I?
No, it's okay. I mean, it's a pretty complex. The problem is it's a pretty complex situation, and I want to make sure we have enough time to cover most of it. So I'll stay fairly quiet. Yeah. But I do want to remind people who are listening in that if you do have questions for either Jennifer or Dakota later, please feel free to use the question tab there on the GoToWebinar control panel, and we'll try to get to those at the end. We'll save about 15 minutes or so at the end to get those questions. So make sure you get those sent in. But no, please keep going, Jennifer. Appreciate it.
Okay, thanks, Dan. And I only have a couple of more slides here. I actually eliminated one slide, which was so complex that all I could do was laugh at it, and I thought that was not a good sign. So I figured maybe I would skip that one for now. But the Yankee group has traditionally been calling this the policy exchange controller. But other people, as I mentioned, call it a diameter router, whatever. what's the benefit of a diameter router in this world that I've described? Well, it organizes all of your diameter signaling, and it provides a lot of benefit. If you're, let's see, it provides a routing hub for all of our diameter messages, and it will alleviate some of your signaling, security, reachability challenges that are inherent in the IP network, and it also will reduce some of the complex mesh of diameter connections that are hampering network scalability and management. By doing this, in doing this, we're going to achieve some lower costs, some streamlined network, assure resilience on the LTE and IMS network. In addition, the policy exchange controller will provide a secure edge, and this is important to external diameter points. These capabilities will allow the diameter router or PEC to improve performance, security, scalability for the internal network, and for communication with the external network. So we believe that, and I guess that's the royal we, I believe that a diameter router should be able to execute the following three functions. Aggregate diameter sessions into a centrally managed device, as we're showing here in this internal diameter routing device, and thereby simplifying the provisioning, reducing the mesh of diameter connections, and also providing some load balancing. Well, I'll get into that in a second. Secondly, provide interoperability in a multi-vendor, multi-protocol environment where diameter implementations may vary, and we all know that there is no such thing as a completely interoperable implementation of a standard. So there has to be some work on the interoperability angle. Route and load balance MME diameter sessions between HSSs, as well as other diameter interfaces such as the GX, GY, RX, et cetera, et cetera. The next slide will show you, I believe, a little bit more of what we're talking about with load balancing the MMEs. And that's going to be, I believe, whoops, there we go, my last slide on this. For an external network, what do we expect from a policy exchange controller or a diameter signaling controller? We want to be able to mediate the network and signaling differences between types of service providers. Ensure that the network resource availability for improved QoS and service level agreement management. We want to be able to route to other service providers and IPX carriers or roaming hubs. We want to be able to provide a secure edge for roaming between the provider network. And we want to further enable voice and data roaming by acting as the enforcement point for roaming agreements. So, just to summarize, with LTE comes opportunity, but also complexity. One of the key areas of complexity is this mishmash of signaling that LTE creates between the various elements in the network. What the diameter signaling controller or PEC provides is a more elegant solution that organizes these diameter messages and in fact achieves then better control in terms of load balancing of these messages, which is a security benefit in and of itself, and a better enforcement point for a better network a topology for enforcing policy as well. So with that, let me turn it back to you, Dan.
Thanks so much, Jennifer. Definitely appreciate that. Thanks for that overview there and diving into some of those topics. Again, like I said earlier, I didn't want to get in there too much because it is one of those topics that is fairly complex, and I'd say for myself, even a little over my head at times. But I definitely appreciate you providing that insight there. That was great. And also, I want to remind everyone who is listening in that again, if you do have any questions for either Jennifer, who just presented, or for Dakota, who'll be next, please feel free to use the questions tab there on the GoToWebinar control panel, and we will get to some of those questions at the end of the presentation today. So definitely appreciate that. All right. Well, now that let's bring Dakota back on here from Tekelec to kind of give an inside-out perspective, I guess, on the diameter and policy market. Dakota has also been kind enough to provide some slides on topics, so let's get to those. Thanks, Dakota, again for joining us, and I'll let you take it away here.
Yeah, thank you, and I really do appreciate the research and time Jennifer put in providing her slides. She's spot on from everything we've been seeing, engaged with our customers. That those are the issues that many of the operators we're working with are dealing with. Especially, I like, where she hit on the congestion control. It's one of the primary issues we've been working with a number of our customers and been working a lot with our CTO office on trying to address these issues going forward with some new functionality and solutions to address that. And the mesh networks is definitely a problem that many operators are working with. So my comments today aren't really focused a lot on the immediate tactical things operators are going through right now. I'd like to share some of the forward-looking conversations that we've been having with a number of operators that we've been engaged with of where they see this all going in the future. But what Jennifer outlined there is very real with what we're seeing today, and I can echo all that. So thank you for your comments, Jennifer. So we've got a shifting mobile value proposition, and to understand the opportunities and challenges associated with monetizing mobile data, we must first look at how subscriber value chain has evolved and is continuing to evolve. So if you click here for the first animation, thank you. As mobile technologies have advanced across 2G, 3G, 4G networks into LTE, so have the types of devices used by subscribers to connect the network. And the capabilities of these devices, the connectedness that they provide, the level of personalization and stickiness also grows exponentially. And the next click, at the same time the network device technology has improved and gotten more sophisticated, so too have the applications and services being used by the subscribers. In the early days of mobile consumer services, infrastructure and value chains are generally managed within the domain of the service provider. However, today, people can do almost anything on their smart devices that they once could do on their desktop or laptop computer, but they can do it on the go, instantaneously, and within the context of whatever is going on in their lives at that point in time. This is a powerful thing, and this is all possible thanks to just what's going on with the industry with fast broadband networks, well-designed mobile devices, and nearly unlimited supply of content, application, services. However, as the nature of communication changes, revenue streams, business models, and value chains are also evolving. These new communication paradigms will open the door to a completely new era of converged communications, entertainment, and social media, something that we like to call the mobile social ecosystem. And with this shift toward the mobile social ecosystem, service providers can also expect to face new competitors that are well-funded, not saddled with legacy infrastructure and operations, and offer devices and services to consumers that are perceived to be more valuable. So what's left to ponder is who will dominate this new mobile social ecosystem. So let's go to the next slide. I think this concept is something that many might be familiar with. So in a traditional voice and text business model, the operator is receiving revenue, and they build out an infrastructure network to handle the traffic coming across that. But what we're seeing now with these smart devices, thank you, is there's, the subscribers now on their smartphones and their devices are now engaged with over-the-top providers like YouTube or Netflix, and a lot of their revenue or revenue that's going over these mobile broadband networks are now going straight to the over-the-top providers. In fact, some studies estimate these over-the-top providers are capturing more than 50% of mobile data application revenues today. Some of the other studies we've seen is the subscribers now spending 60% of their time, of their internet time over these smart devices with these over-the-top providers. So it's creating an extreme challenge for operators now as they are burdened with the building out the network and infrastructure to handle all this volume of data traffic, but they're getting marginalized on their revenue opportunities. And so what we find in our conversation with customers right now is they're really trying to be innovative and thinking of new ways that they can leverage the competencies they have with their data infrastructure to generate some new revenue opportunities for themselves and also create value and drive value to subscribers. I want to pause for a second and on this next slide talk a little bit about kind of a continuation from where Jennifer was talking about, is talk about the signaling traffic that is booming and is expected to boom because of some of these shifts in the industry here. So, and there's a lot more detail about the diameter signaling traffic. The way we think of it, we've got some white papers at tekelec.com that you're welcome to look at and read. We have a diameter signaling index where we've spent a lot of time trying to benchmark and forecast and predict the various elements that can drive this kind of traffic. But much of it, as Jennifer has said, is driven by policy, right? As operators are not only trying to use policy rules to better operate their networks and manage their networks and drive efficiency there, policy is absolutely instrumental to delivering new value-adding services to subscribers, and also setting up potential two-sided revenue sharing agreements with over-the-top providers. Anytime you implement a policy rule for whatever the reasons the operator might think about, is going to drive a disproportionate amount of signaling traffic behind the actual data that's being asked for by the subscriber. Projections from our calculations would say that we got a 252% CAGR, driving this up near 47 million by the year 2016. 47 million MPS, I should say. So certainly thank you. So certainly the growth is attributed to growth in subscriber growth. Multiple sessions per subscriber, concurrent data sessions is a big driver of that. Complexity of policy use cases. And then also this increases charging interactions with policy and policy enforcement points. So the more sophisticated and personalized data plans get, the more traffic one's going to see. So back to the problem statement then of what are operators needing to do and what are some of the thoughts that they're thinking about. To address these challenges while remaining competitive, service providers must not just apply brute force measures to control traffic and raise revenues. The unique needs of different types of subscribers must be managed. And it all starts with the realization that not all subscribers are the same. Different subscriber types can have very different requirements in terms of quality of service, usage models, device preferences, roaming patterns, time of day patterns, and so on. Another big thing that operators need to think about is not all devices are created equal. So if we can go to the next slide there. Yep. Additionally, the variety of device types adds another dimension to be considered when defining new services and rate plans, as different devices typically imply different usage behaviors based on the capabilities of the device, how mobile they are, whether they are more for casual or frequent usage, what types of applications they are optimized for, and so on. As a result, different devices also levy different requirements on the network signaling and bandwidth profiles. Combined with the facet that increasingly we are seeing many users have multiple devices, and the situation requires comprehensive and elegant solutions to enable truly personalized and differentiated offers. So what many operators are facing now, looking forward, is maybe one of three or a combination of three business models that they could pursue. So a transformation of the service providers. So a mobile service provider today, in the end, we can see an evolution where service providers will assume one or possibly more of the following personalities. They could be an access provider only, whose primary business model is to provide low-cost, commodity network transport of basic services, similar to the utility model, at much lower margins. 8 to 10% maybe, rather than the 30 or 40% seen today. Or they could contemplate being a service enabler, which in which they'll provide a more robust network, APIs and subscriber data that powers the most useful and popular consumer applications and services, which are managed by providers optimized to deliver such services. And the last area that they could contemplate is becoming more of a digital lifestyle ecosystem provider. This is where they can provide an ecosystem leveraging social media, entertainment, rewards program, mobile commerce partners, etc., all with the aim of building strong customer brand loyalty. As we mentioned, today's service providers can assume more than one of these roles, but it is our belief that each role must be established as an independent operating entity that is managed to meet the unique business requirements that are dictated by each model, which includes organization, infrastructure needs, pricing models, marketing, customer support, etc. The belief is that as operators move more into the domain of close subscriber engagement and personalized experience, the more valuable the operator will be perceived by the subscribers. So digital lifestyle providers need policy everywhere. So similar to what Jennifer was talking about, we also believe that policy is going to expand beyond just managing the operations of the network. But we really believe that policy will be everywhere, pushed outside the core of the network, all the way out to devices, machine-to-machine use cases, and cloud engagements and so forth. So we believe that operators need to embrace the concept of policy everywhere. Policy is the engine for innovation and differentiation. And in the policy everywhere paradigm, its role evolves dramatically from its current usage. Okay, so we also believe that policy will be defined centrally with an intelligent control layer that is independent of the underlying network infrastructure and applied globally across networks, devices, and applications. It will intelligently orchestrate the subscriber's experience leveraging the network, subscriber, device, and application awareness, and diameter signaling routing. So certainly, there's a lot to, what I'm talking about here is, could be, years down the road, but this is the direction that we see that operators need to be thinking about as you might apply policy rules to your own subscribers as they roam from your home network to a visited network and so forth. There would be an increasing desire as an operator wants to become more sticky from the subscriber's perspective of driving value to them, that they would need to somehow apply a parity level of quality and service as they roam across networks. So figuring out how to align policy rules across operators, across networks while roaming is certainly a complex thing. We believe that, as I mentioned before, that policy is going to have to be really at a centralized, integrated control layer that is probably abstracted in a software-defined network and abstracted away from the underlying core, hardware infrastructure. And as this begins to happen, operators will really be able to leverage the opportunities in a mobile social ecosystem. And eventually, the technology, I believe, will begin to evolve down to a path where operators or those who want to move into the space will really be developing and building a thinking network, a network that is smart and can react real-time based on where a subscriber's moving, where he's roaming. They can make real-time decisions about whether to offload them to Wi-Fi, for example, or to engage a promotion with over-the-top provider that the operator had negotiated maybe previously in a contract. So there's a lot of opportunity for operators to get creative in working with over-the-top providers in generating revenue opportunities, and also bundling these things and packaging these things in a way where the operators themselves can be the digital lifestyle provider. And we're even seeing some of this language and some of this thinking at many of the operators' websites today as you go through some of the things that they're thinking about. So I know I've probably used up my time. I don't need to go through this slide here. Certainly we can, this just goes through the use cases or an example of how this might work. A subscriber could be, as he's maybe going to a football game, the operator's intelligent network recognizes immediately that there's the operator has a Wi-Fi spot at the stadium and can choose to offload them to Wi-Fi. Maybe at halftime, then the subscriber launches an application to purchase an application, and the operator has negotiated agreements with various advertising agencies that will push that down to the phone in real time. That might also deliver a discount off the subscriber's monthly bill. And which all can be effective in real time as the thinking network adapts to this. And this could generate a lot of revenue for the operator as he's bringing in these revenue streams through the over-the-top providers, ad agencies, and so forth, and also from the subscriber themselves, as they might choose unique packages that are very customized to their preferences and their usage.
Got it. Well,
so again, like I said, oh, go ahead.
No, I was going to say, yeah, well, yeah, thanks again, Bob, for the presentation there. You know, obviously, you know, the path you guys are looking at is a new one for a lot of these carriers, but something that I think it seems like they're interested in, and a good way to monetize these IP networks. So definitely appreciate the insight there, and thanks so much for the presentation there. What we're going to do now is kind of leave the last 10 minutes or so here for some Q&A. We've got some questions in already. I definitely want to remind everyone too that if you do have a question for either Jennifer or Dakota, to please use the question tab there on the GoToWebinar control panel, and we'll try to get to as many of these questions here as we can. The ones that we don't get to, we'll actually keep some of these questions, and we can pass them back to the panelists. They can follow up with you guys with afterwards as well if they have time. So anyway, so let's go ahead and move to the Q&A section here to kind of see what people are wondering out there who are listening in. So looks like, and for these questions here, I'll try to direct them to the right person, but obviously either Jennifer or Dakota, please feel free to chime in on either one of these on these questions. So one of the questions someone asked early on was, I guess, the use of diameter in 3G. Is diameter used in 3G, or is that strictly an all-IP type of protocol usage? I don't know, maybe Dakota, if you have some insight on that there.
Yeah, I can take a stab at that. So we are seeing the most common 3G use case that we're seeing is with online charging systems, particularly the data charging is the diameter interface, GY interface. The voice is still running over Camel, for example, but so as operators have 3G subscribers that are surfing the web per se on pulling that mobile data or that data traffic down, that runs over a diameter interface, GY. So there are some 3G use cases for diameter.
Gotcha. I mean, Jennifer, I mean, are you seeing a lot from carriers who are, I mean, 3G is obviously still, a major part of a lot of carriers' networks, and internationally too, it's still a big part. I mean, I guess what's the call for using diameter with 3G from what you're seeing?
I didn't hear the last part of that, Dan. What was that?
Oh, just getting, I guess, your view on kind of the use of diameter for 3G networks and the need for that.
Gotcha. Well, diameter, and I'm noticing some of these other questions here, so I'll try and also touch on a couple of other ones. Diameter is, in general, part of the 3GPP. It's most of the LTE implementations and any IP implementation specify a diameter routing agent. It is not necessarily a diameter signaling controller, i.e. from Tekelec, or what the Yankee Group calls a policy exchange controller. So it's not quite as feature-rich as what we have been talking about predominantly here on our webinar. But diameter routing agents are implemented in most of the policy implementations that you see. So we do see, because there's a lot of diameter signaling out there, we do see a lot of diameter routing agents that have been implemented. They are not as feature-rich. They're usually targeted at traffic management implementations in a 3G network.
Gotcha. Okay, all right, that makes sense. All right. Let's see, some more questions here. Looks like someone's asking, maybe this one's geared towards maybe Dakota. Does any IPX provider have plans to deploy diameter signaling controller specifically in the diameter edge agent?
Yes, I can answer that. So yes, that's a true statement. We're engaged actually with many IPX providers. Some already have deployed diameter signaling routers as edge agents, for a lot of different use cases. But the interconnect reasons, the interoperability reasons, also congestion control management at the edge are all use cases that they've been looking at there.
Gotcha. Okay, and it looks like that person had a follow-up question too about what are the throughput requirements, diameter messages per second for diameter signaling controller? Maybe Dakota has some
Yeah, I'm not sure exactly how to answer that one. I can share certainly, how many messages per second a diameter signaling router needs is really a function of the operator's, projections of, it's just based a lot on the scale of their network, how many subscribers they have, and so forth. So, it's going to be different from a large network versus a small one. But we've seen, diameter signaling router deployments that we've been engaged with ask for anything from, a couple thousand MPS to handle their subscriber base, all the way up to requests, north of 500,000 to 900,000 messages per second. 500,000 messages per second or more to handle the amount of traffic that they're projecting based on, their network demands from subscribers and concurrent sessions and so forth.
Gotcha. Okay. And I think we had a question here, and it's also a topic that I noticed a lot when I was working on the report, kind of looking at, I guess, the role of 3GPP in standardizing the space, but just kind of, and also, I guess, the interoperability of the diameter space. It seems like, at this point, the companies involved in diameter are perhaps maybe some of the more focused companies on the space, but there's thought of some of the bigger players perhaps coming in at some point down the road, and there's some questions about whether there might be some interoperability issues moving down the road. So maybe start with Jennifer. How has the role of 3GPP in standardizing the space been moving along, and do you see any concern at all about any sort of issues with the standardization of this or interoperability of diameter going forward?
I'll be frank. I have not. One would expect that there would be issues here. However, I have not seen any specific examples of interoperability issues arising. And actually, perhaps Dakota has some insights into this.
Yeah, maybe Dakota, if you've seen some. And obviously, again, I guess from what I found too is the nice thing about diameter is its kind of core tenet is to facilitate interoperability. So perhaps that might be a reason why it maybe isn't much of an issue. But maybe Dakota, if you can maybe comment on the 3GPP standardization and operability of diameter.
Yeah. So I'll do my best to take a stab at that. So first, we are extremely actively engaged in working with 3GPP to try to influence and drive some of the standards around things where we think the initial rollout of 3GPP didn't maybe address. So already, just even in all the diameter interfaces out there, we're seeing variations of those interfaces, and that does create interoperability issues. And so we found just in the development of our own products that we've had to account for that with a lot of mediation ability out there. So being able to drive some congruence or standardization around interoperability would be, I think, extremely useful, and I would imagine there's be more discussions on that as well. And also we found that 3GPP hasn't outlined a lot of standards as it relates to congestion control and some of these overload issues that Jennifer was talking about before, and that's something we're actively engaged in because we believe those are absolutely essential to a stable, reliable, and scalable new diameter network that operators are going to need to be able to continue to provide the quality of service that everyone expects going into a much more complex environment.
Yeah, interesting. I think I was talking to one person about this topic, and they had mentioned that I think in the standard itself that there was dozens of references or uses of the word may in there, which tend to kind of provide a little bit of leeway for those using the standard. So that was probably one of those things that needs to get sewn up at some point. But anyway, so we have definitely a lot more questions here. I think we have time for maybe one more on the webinar here. Looks like we got one. Someone's asking. Signaling is growing rapidly, but in terms of bytes per second, how does signaling compare to bare data traffic? Does signaling represent 10%, 20% of the data traffic? So I don't know if maybe Dakota, what you're seeing on that.
Yeah, I can talk to that, and I meant to mention it on the slide that I had on the signaling index that Tekelec's been doing a lot of research and benchmarking on. So sorry for omitting that. So what we've been seeing is that the signaling traffic for all the mobility management is going to be at least 3x of the data traffic growth. In fact, when we shared some of those findings with some of the larger operators around the world, they said, their response to us was, well, we're already seeing more than that. And so I think there definitely is evidence that signaling traffic is going to be on a more steep growth curve than the data traffic.
And if I can jump in here for a minute, keep in mind it is signaling traffic, so we're talking small packets, and it will be a fraction of the overall traffic load on the network. However, it's a critical element of the traffic, so it will be maintaining. The service providers are implementing a fairly limited number of classes of service right now. However, the general management of the network will have an extremely high class of service, and signaling will as well. If the signaling traffic doesn't get through, then nothing else gets through as well. So although it constitutes a fairly small percentage of the overall network traffic, it's a critical element of the traffic. And if the signaling network goes down, or if there are problems with the signaling network, nothing's going through.
Yeah, that's a good point too. I think, like you mentioned too, Jennifer, I think several carriers have experienced maybe some of this as well at some point in their deployment. So, like you said, it's a pretty important part of the equation as well. So, maybe we'll throw in one more question here if possible. It looks like someone's kind of looking at maybe some legacy, starting out with SS7 before moving to diameter. Any sort of issues, or what's, I guess they're saying, what's the rule of thumb that you use to calculate kind of the move from SS7 jumping up to diameter? What are you guys seeing as kind of the tipping point there? Maybe Dakota, if you have some comment on that part of it.
Yeah, so I was just thinking about how I might address that. So, we've built some real complex models that there's so many variables that influence this that I'd probably steer a customer or someone to first pull down the signaling index white paper that we've written, and then we'd like to engage because we want to make available that model to people who are trying to project this. And we've been doing that with some of our customers because there's just so many variables that impact that. It's hard to really say that if your SS7 traffic is such, then your LTE traffic will be thus and such. It's hard to do. Gotcha.
Okay. All right, that makes sense. All right. Well, that sounds good. Well, again, looks like we're just about out of time here. I definitely want to again thank everyone for the questions that were sent in. I think we didn't get to a few of those there, but definitely thank everyone for sending those in. And like we said earlier, we'll be sharing the list of questions or unanswered questions with our panel members who, if time allows, can follow up with you individually. And also on the screen there, you can see email addresses for the panel members. So if you have any specific questions, you can send off those questions to them individually. Also, let everybody know that this webinar will be archived on the rcrwireless.com site in a few days, and please look for that if you want to rehash this topic. And also look for our report on this subject. It should be on our site this week as well. Some more details on the topic. So we definitely appreciate everybody joining us today. And also, before signing off, I want to also thank Tekelec for sponsoring this webinar. And also thanks to everyone for participating today, with a special thanks to Jennifer and Dakota for providing the insights on this. Obviously, like I said earlier, it's a pretty in-depth topic and probably hard to cover in an hour, but we definitely appreciate you guys providing some insight at least into the topic and perhaps providing some avenues for further discussion on this. So thanks a lot for joining us on that. And I want to thank everyone again for joining us today, and for everyone have a good afternoon. Thanks again.